Good evening, everyone. Vilid speaking. Another day of presenting our project, dog breed detection. Our project, which aims to help individuals use our application to detect dog breeds. So before we hop into the pre-processing and modeling part, just remember our data set on Kaggle, named dog images. Next. Firstly, in case you'd like to have a look on our data, again, it has 20,600 images in GPG format, 120 classes representing dog breeds, and as for the average number of samples in each class is between 170 and 180. So while analyzing our data, we came up with two problems and we worked on two solutions by ourselves. The first one is that images of humans' bodies exist in the dataset. So we found out that we can drop them and replace them with other pictures from the internet. And the second one is that some classes are low on the number of samples. So we'd either merge classes with each other, depending on the case we're working on, or gather some pictures from the internet. Thank you.
Hello, Chata speaking. I will talk about the explanation and definition of preprocessing before the graphics and datas. When building a machine learning project, one thing we always need is data. In this case, image data. And image data preprocessing, which converts image data into a form that allows machine learning algorithms to solve it. And there are several techniques used to preprocess image data. And these are grayscale conversion, which is simply converting images from color to black and white. It's normally used to reduce computation complexity in machine learning algorithms. And the other one is normalization, also referred to as data rescaling. It is the process of projecting image data pixels to a predefined range, usually between 0 and 1 or -1 and 1. This is commonly used on different data formats, and you want to normalize all of them to apply the same algorithms over them. Normalization is usually applied to convert an image's pixel values to typical or familiar sense. And data augmentation is the process of making minor alterations to existing data to increase its diversity without collecting new data. It's a technique used for enlarging a data set. Standard data augmentation techniques include horizontal and vertical flipping, rotation, cropping, shearing. And last one, image standardization is a method that scales and preprocesses images to have similar heights and widths. It rescales data to a standard deviation of 1, which is unit variance, and mean of 0. And you can go to the other slide, begin. Why is important? Preprocessing is required to clean image data for model input. For example, fully connected layers in convolutional neural networks require that all images are the same size arrays. And image preprocessing may also decrease model training time and increase the model inference speed. Now, Mert, you can continue with CNN.
Hello, I'm Mert. I will give a brief information about CNN. CNN is a deep learning algorithm that can take images as inputs and assign importance to some aspects and objects in the image to be able to differentiate them. CNN is able to learn directly from data, thus it eliminates the need of manual feature extraction. Other than that, the need of pre-processing is much lower in CNN compared to other classification algorithms. CNN consists of different layers. It has an input layer to take inputs, an output layer, and can have many hidden layers in between these two, like pooling layer, flattening layer, etc., as we also use in our model. After learning features, CNN shifts to classification. Now Bilge will continue.
Hi, it's Bilge. I want to talk about our code. First, I added all the libraries I will use before all operations. First, I want to talk about one-hot encoding. One-hot encoding makes the representation of the categorical data more impressive and easy. Many machine learning algorithms cannot work directly with categorical data, so categories must be converted to numbers. This operation is required for input output variables that are categorical. Then I used a shuffle. Before pre-processing, I would like to talk you again why our data needs pre-processing. Teacher, this is a difficult data set because in some cases, more than one type of dog is in an image. In other images, the number of pixels occupied by the dog is a small percentage of the pixels for the entire image. If we resize to smaller image size, the number of pixels of the dog, shrinks the proportion. So the model ends up with very useful pixel for feature extraction. Here you can see that the photos need to be resized. In pre-processing part, since the number of photos is very large along with the photo size and the number of classes, as you know, our machine learning models train faster on smaller images. So we need to resize, but we had memory problems. If it was not possible to take entire data set to memory and feed it to the model, from there, so the pre-processing part was not possible. We did it on separate site. As you know, pre-processing is required to clean image data for model input because fully connected layers in convolutional neural networks require that.
Bilge, I can suggest you use TF Data API, TensorFlow Data API. If you check on the TensorFlow website, you would see that to handle such problems about memory with large data sets, actually your data set is not large, but if you apply TF data pipeline, which is data pipeline especially designed for TensorFlow, you can easily handle such problems. You just write a very basic code by using the examples in the TensorFlow data pipelines. Also, I share 3 or 4 tutorials about how to use the data pipelines. You can check. Especially, I have one for image data sets. You can use the codes that I share in that tutorial. Easily, you can handle large data sets without facing any problem in main memory. Okay.
Thank you, teacher.
Okay.
I will check.
Next time, maybe you can use it.
Yes.
If you have any problem, just drop my office. I could share the collab notebook as well. Okay.
Thank you so much. First of all, we did data augmentation by applying various rotation operation to the photos. Augmentation involves altering the training image to generate a synthetic data set that is larger than your original data set, and will hopefully improve the downstream performance of our model. After data augmentation, we have a data set of approximately 30 more than 300 date photos. Since the size of
Bilge, could you specify how many classes now you have? How many images per class after augmentation?
Teacher, you said us if you want to concatenate some pictures, you need this made by a professional. I wanted to concatenate all pictures, some pictures.
We are talking about classes, not the pictures, right? We are talking about classes. These are the dog classes, the breed types, right? If these some breeds are very close each other, I suggest you to combine these two classes or three classes together so that images per class number would be increased. You mentioned this, right?
Yes, but I afraid to do this because if I think this is so similar, but maybe I can disrupt the model when it's learning, you know.
Okay, I understand.
Because I wasn't sure.
Okay, according to your decision, what is the class number right now? How many breeds?
Now it's still 120.
120 classes.
But we did data augmentation.
Per class, how many images after data augmentation?
Per class, 4,000.
It was 110 or 120 before the augmentation. Am I right? After that.
Yes. After that, each class has about 4,000.
Okay. Let me ask you, Bilge, one question. How can you specify how many images in the end you will have in this code?
How many images?
How can you control that in that code? For example, instead of 4,000, if I would like to have only 2,000 images, can you control on that code?
I can control.
Where?
I think here. Because I created a classer for this folder, and I think here.
Okay, let me ask your teammates, Mohammed.
Yes, sir.
Mohammed, how can you control the number of images in that code? If you would like to have only 2,000, for example, after the data augmentation, how would you change the code? Do you know?
No, unfortunately, I was not on this part as I was in Istanbul.
Okay. Mert?
I don't know as well.
All right. What about Çağatay?
Same as teacher, we don't know anything about this.
So my point is that you need to understand how such a code works in your situation. So as you know that on the internet you can easily find any kind of code and you can make it work, I know, but you need to understand how and why they work and how you can update, change it for your purposes. Bilge, is that clear for you as well?
Yes.
Okay, so for everyone, I will ask such questions because I don't want you just copy and paste, because I am very aware of that. There are lots of blogs, for example, my blog as well. I am sharing the code, but the code is not important. But you learn how to use codes and why you need such codes and how to update these codes according to your needs. So it's my priority that you learn what you are doing. I don't want you just copy and paste and make it run. So please be aware of that. I will ask such questions, especially in the code review. After 5 weeks later, we will have a code review session. Everybody must be ready to answer such questions. Is that clear for everyone?
Yes.
Okay, for all teams, of course. All right. Bilge, let's continue.
Since the size of this data set is very large, by applying the grayscale and resize process, we have reduced their size and made them ready for training. I had to split the data before modeling. I trained the model without augmentation. I want to tell you this, teacher. Therefore, since the dataset is small before augmentation,
Bilge, I would like to interrupt at this moment. Could you go one slide back? As a presentation technique, it would be very beneficial for the followers, audience, if you show us the original picture, an image of a dog image,
I
and
did,
then
teacher.
how it's changed after these augmentation techniques.
Like that.
Yes, but what is that operation on it? Which operation is that?
This is rotate.
Yeah. Do you understand my point, Bilge?
Yes.
So if you go back your code again, okay, here, yes, here you do the rotation, shift, shear, zoom, flip, and of course you need to do rescale, no problem with it. But these 4-5 techniques, you can show, apply only one of them on an image and explain the resulting effect on the original image. So
I understand you, yes.
as a presentation technique, it would be very beneficial for your audience.
Yes.
Before going into the details of other model results. Okay. Okay, let's continue.
Therefore, since the dataset is small, before augmentation, I did not want to separate it for testing and loose training. You understand me, teacher? I'm not sure if I'm clear, because I split it 18% of the data for training, and I reserved the rest of validation. Before prediction, I adjusted some important things.
Bilge, let me clarify something. You need to split, train and test all the time. Otherwise, you are not gonna ensure that your model is working as expected. It could easily overfit, you know, that problem. So first of all, even you are talking about your data set is little in number, but last time you said that 4,000 images per class. Am I right?
Yes.
Why now that's not like that?
4,000, not every class. Teacher, this I did not add data augmentation, because yesterday I did data augmentation because I was searching on internet. I was learning. I'm so sorry for it, but I yesterday night.
All right, let's sum it up. Let's clarify.
Yes.
Now you are talking about that the test size is just 20%, right? Do not call it validation, because validation means that you use this data to model selection or fine-tuning, hyperparameter fine-tuning. For two reasons you use the validation. Okay. But you always need test data set. So for everyone, I would like to clarify that if you are training a model, if your data set is fewer in numbers, first you need to increment it somehow, collect new data or apply data augmentation. But whatever you do, there is no excuse that I cannot split, train and test. Otherwise, don't begin with that data. Do you understand me?
Yes.
The second thing, the difference between the validation and the test data is that validation data is used for model selection. Which model you are gonna select, you apply the model, check with the validation data. The one with the highest score with the validation data will be selected as a candidate to test with test data.
Yes.
Or you can use the validation data set to fine-tuning the hyperparameters. How many layers you will have, how many neurons in each, what would be the filter size. So you will apply different hyperparameter values by using the validation data set. After you freeze your model, you need to test your model with test data. So you need the test data all the time. But you will use the test data as a last step, not during the
you're right, teacher.
model selection not during the setup hyperparameter values. Do you understand this?
Yes, I thought I will split test after I add data augmentation folder.
So you need to first apply,
Yes.
train and test. After that, you do second split from the train. Again, train and validation this time.
Okay, teacher.
Okay. So, and if you have already data augmented, please use this augmented data set. All right.
Just yesterday night I did.
Understand you, but for the future.
Yes.
Okay.
Okay.
Let's continue.
Okay, you can see I adjust some labels, bait size before prediction. And finally, this is our initial model. As you can see, the model starts with the input layer. You can see here 64 tree. This is input. The reason I chose 64 size.
Can I stop you at this moment?
Yes.
I think did Çağatay explain the convolution neural network or Mert? Who explained this?
I did, Mert.
Mert, could you please explain this code for us? Because you already explained the convolution neural network.
Yeah, but I don't have the knowledge about the code.
But you are supposed to know, right?
Yes.
Okay. What about you, Mert? What about you? I am sorry, Çağatay.
So we are working on mobile application part, not the machine learning all codes. We are not know them.
But as
we don't
I
know them.
explained it, everyone.
Yeah, I know you explained that. Sorry for that, but we are working on already mobile application parts.
Whatever you are working on before the presentation, you need to train
we need
yourself.
to know all of them. Yeah.
Okay, you need to train yourself.
Yeah.
One of you is the teacher. He or she would teach you, and everybody else learn. So we are moving on
Murat.
as a team. Okay.
Yeah, sorry, Vilid speaking, the project leader. The problem is that we do not have a meeting that Bilge takes her chance to explain the code to us. Maybe she does not want, or maybe she's keeping it for herself. Thank you.
Okay, but just come together, all right, and CC your emails to me. I would see that you are gathering for teaching you each of you.
Yes, teacher.
Sure.
This week,
Okay.
like that, because our.
Do you understand my point, right?
Yes, yes.
I try to make my point clear. Everybody understanding that I don't want to blame you, but I already sent an email explaining this. Please follow the rules, okay? Otherwise, you will fail in the code review. Okay? And I don't want you fail in the code review. Is that clear for everyone?
Yes.
Clearly understood.
Okay, so I try to help you before the problem occurs. All right, let's continue.
The reason I chose a 64 size was that the photos were too large and high quality. I found it more convenient to reduce them and give it them as an input. It's in the state. Each layer has, you can see, batch normalization because it serves to speed up training and use higher learning rates and making learning easier. You can see last layer, our activation function is softmax because we are doing a multi-class classification. Now it's possible to see the summary of our model here, the layers and the model in the model. The output you can see the output shape, number of parameters. You can see the total number of parameters.
Okay, at this point, I have a question for all of you.
Okay.
You have a custom convolution neural network, right? Custom
Yes.
one.
Yes.
But why didn't you use transfer learning?
Transfer learning.
Yes. Why didn't you use transfer learning? Anybody knows what is transfer learning?
No.
Maybe the other team members?
I was learning by myself.
What about the others? Çağatay, Mert,
I know.
Ferit.
Oh, sorry. I'm sorry.
Anybody heard transfer learning?
I just know that it is a machine learning method for training the model. This is what I know about it.
Yeah. So actually transfer learning means that we have some models already trained with some data, similar data, related data, probably much more data. Then we can use this model and customize this model to our problem. And we hope that we can transfer what it learns before the previous data set and get accustomed to our data set easily, convert to. Okay, so please note this, and next time I hope that you will apply transfer learning.
Yes.
And you will report the difference between your custom model and your transfer model, transfer learning model. Okay, in the next presentation, I would like to see the results of these different two models at least. Okay.
Okay, teacher.
Okay. Please note Mohammed and
Okay.
coordinate this. Okay. Let's continue.
Teacher, if you ask me why you choose epoch 50 as the epoch number, we have chosen our epoch number as small at the beginning in order to see the results in short time. We also updated the model according to learning status. As you can see, our model is underfit, teacher. Is really underfit. I can say is not even learn anything. I'm still searching the reason of it. Maybe it will change after I added a data augmentation folder.
Okay, let me notify something. If the validation accuracy is so low, most probably your data is incorrect. Either the labels are incorrect or the data is incorrect most of the time.
I didn't understand. I tried anything to improve this,
but don't try to improve anything. Check your data.
Okay.
But I am saying that if validation accuracy is so low, it's not the model to blame. It is the data or the label. Maybe you are incorrectly find the labels.
Maybe, teacher.
Maybe the data is not correct. The data itself is not correct.
Yes,
For
teacher.
example, the one breed of the dog, there are many breeds in that dog folder or in that class. Do you understand me? Maybe your data is not correct, but because it's impossible after 50 epochs that a convolutional neural network ended up with 6% validation accuracy. It's almost impossible.
Yes.
So there should be something wrong in your data, either images or data labels. Check this.
I did something about labels. Maybe I was wrong. Maybe I can come
Check
to
this.
you
Okay,
and
by basically print
Okay.
out the image, print out the folder, then print out the one-hot encoding and check that they are all correct. But
Okay,
I believe
teacher, I
that
will
one of
check.
them is incorrect.
You're right. And I want to show you some picture after data augmentation. I did this. You can see the rotation. And I saw after the data augmentation, you can see the grayscale of the pictures. As I said, this is underfit. We are still working on how.
Actually, it's not called underfit. It
Yeah,
means that your model does not work.
Yes,
Okay.
teacher. Yes,
And
teacher.
one more thing, you don't mention any metrics. Since you are doing multi-class classification, don't talk me about only accuracy. I don't care about accuracy because in multi-class classification, accuracy is not only the metric that you care for. You care for mostly F1 score or other scores. Please check these metrics for multi-class classification, and you can find my tutorial on how to evaluate the models with multi-class data sets, and there are others. You now use only accuracy to report, but it's not useful because you have 121 classes.
Yes.
Assume that 10 classes you have 100% accuracy, but the other classes you have only 1% accuracy. Are you gonna be happy with that?
No.
So accuracy is the average accuracy of all classes, and micro and macro, whatever, you have other metrics. But check F1 or recall or precision and micro, macro, and average. And you need to check on this and learn on these the differences. Use the scikit-learn classification report metric.
Okay, teacher.
Okay. And otherwise, don't just talk about the accuracy. Of course, in your model compilation time, you can use the just for the loss, you can use the categorical cross entropy because you use the one-hot encoding for the labels. But for the metrics, it's not important here what you use, but after the testing your model, you need to report F1 score and precision recall with respect to micro, macro, and average calculations. Okay? Then you need to be ready for comment on these metrics. All right?
And what about optimizer, teacher?
You need to try and see it.
Okay. Okay, teacher. That's it. Thank you for your attention.
Okay. So for your group, I suggest you to work on together. And Velit, please keep me on the in the loop so that I can see that you are coordinating your efforts. One learns something, and this guy would be the teacher for others. So you have several things to do. As in my email, I explained this. I would like to see that everyone is working as a member of a team. So I don't want to see only individual success, but I would like to see that you can cooperate with together. Okay, that's important. One of the object of the graduation project. Am I clear?
For sure.
All right.
Thank you, teacher.
So I want to ask something.
Okay, thank you for the presentation.
So
please improve it. We will do another presentation. You know that in that presentation you are gonna present the model performance in detail. Okay?
Okay.
But learn the related topics.